What is up, guys? It's YouTube. Today we'll be creating this spring in FreeCAD using finite element analysis technique. So let's go in and see how it's done. I already have prepared myself a spring over here, as you can see on my screen, and this is going to be the animation for it all. It's going to be bouncing up and down, not left to right, and yeah, basically that's our main goal for today. So let's start the video and not waste any time. If you're wondering why is my FreeCAD looking a bit weird, it is because I'm using a different theme, so your part design might be a little bit different. Firstly, we go with part design and create a sketch over here on the XZ plane. We'll be creating a spring, so let's have a circle over here with a diameter of about 3 millimeters, and the distance, let's have it at 10 millimeters away from the origin. Let's leave that. Then we're going to go into the additive helix, which creates us the spring itself. For the pitch, we're going to go with 33 millimeter. No, the pitch is going to be 6, and height is going to be 33. Let's go with that. Let's see how that looks. That's about right. What I'm going for is that there's two holes here in the front. If you want to have different dimensions, go for it. And basically this is what we're aiming for. And now, as we have our body created, we should create the finite element analysis. And for that, we'll be heading ourselves to the finite element analysis workbench. And here we have to create the simulation container over here, analysis container, let's something like that. And then we have to add our constraints, features, and a bunch of other stuff before we can start simulating it. To begin with, we'll start with the constraint that is the bottom. We press over there this, sorry, I rushed a bit fast. There is fixed boundary condition. We press on that one, which means this part or face or point will be locked in, not moving. We press add to add what face do we want. Then it's going to light up like this. We press OK. And then we're going to add the force that we want over here from the top to push it on the bottom. For that, we'll be using this one, force load. Let's click on it. Then again, press add. Then we're pressing on the circle over here. As you might see, the force is going to be perpendicular to it, but we must change it so it's like up and down. For that, enable origin then over here on the right side, or whichever, or left side it might be. There's going to be a button for direction. You have to click on the direction first. This can be axis or someplace on the part itself. So I'm going to click on the Z over here. Okay, maybe direction and then the Z. That's where it worked. Okay, here we go. It did work. Some weird stuff happening, but as you can see, it worked. It's working, but it's pointing upwards. For that, we reverse direction, and it's going down now. You might think we're done, but no, unfortunately, we have to edit it a bit more, because currently, if we leave it as is, it's going to go to one side, and we don't want that. We just want vertical action, and for that, we are going to use this one tool, this rigid body constraint. Let's again press add on the top part over here. What is this doing is basically constraining it to different sides and what it can do. And for translation mode, we're going to change these to constraint X, Y, and leaving the Z on free axis as it can move freely. We don't do anything with the values, just X, Y for rotation and translation constraint. We press OK. Now the next thing that we need is to actually create the geometry that is going to be manipulated, and for that we go to select the body, and over here on the top bar you should find yourself mesh from NetGen. Basically it creates a triangulated mesh, or sometimes it can be also quads or some other geometry. Basically we're going for this one. And once you click it, nothing's going to be happening unless we change some details and press OK. So these top two details are how big are the triangles, or like how big is the object, not the object, but the smallest individual pieces that are going to be constructed the whole thing. If you have a lot of them, the simulation is going to take a long time. If you have too few, your simulation is going to be choppy. So you got to find like a balance for it. So for the minimum size, I like to go for 1.5 for this case, and a maximum size of 6. If I press apply, it should show us the geometry over here. I said minimum size of 15. No bueno, guys. I think it's going to be chopped. I guess my numpad on the keyboard is not really all that well. So yeah, this is not great. What I wanted to do is have the dot over here 1.5. 1.5. There you go. Can I have it, please? FreeCAD. Okay, thank you. Okay, now we can hide the original geometry, and now we can have a nice, beautiful mesh. I would say it's perfect, but there is some inconsistencies from over here. The topology is broken a bit. As you can see, it is not flowing. It could be flowing, but most likely it's fine. It's not that bad if it does that. And so yeah, we just apply it and move on. Let me apply. Then we can move on actually to simulating the whole thing. Let me get to the front. Okay. Yeah, we are actually very far, very close to simulation. But before that, we have to go into the material and assign it a specific material. What is it? Aluminum, wood, plastics. And here over in materials, you can select all kinds of materials that FreeCAD has to offer. What I want you to be mindful about is what kind of material you choose, because, for example, once I choose this aluminum, I have to see does it have Young's modulus and Poisson ratio. If it doesn't have these two values, simulation cannot be done. These mechanical properties are fundamental to making the simulation possible, so make sure that the material you choose has those specific properties. Once we have that, we are basically ready to create the simulation. For that, we double click on the solver over here, and then we write imp EINP file. Once we have that, we can run the simulation over here with the start calculi x, and we can see our geometry over here. We can hide the results on the left side, close this bar, and what we're aiming for is the CCX results. We double click those, and then we can see our simulation, and then we can start animation. It should be started pretty soon. Oh, it's so weak. Did I forget to add the force? Yeah, let's do 100 newtons force. 1 Newton force is just like, you know, a little bit of nudge. Let's have a bit more. To reset our simulation, we go over here in the solver, write in file again, go through that process, start the simulation. It runs through, we close it, we go back to results, double click it, and there we go. We have our simulation done. Let's see the animation. Beautiful. You can play around with the numbers of animation control. I have it set on 120 steps per cycle and frame rate of 30. And so yeah, this is how you create the spring animation here in FreeCAD for your simulation. You can change different types of values over here, see where's your model stressing at. As you can see, the bad geometry is being stressed a bit more than all the other geometry, but besides that, this has been tutorial how to make a spring, and I hope you found it useful. If you did, drop a like, smash subscribe, and I'll see you another time. Ciao!